Lockheed F-104 Starfighter was the first interceptor to fly at sustained speeds of twice the speed of sound, breaking numerous airspeed and altitude records. I'm Paul Max Moga, and I've flown some of the most sophisticated fighter aircraft ever built. Because of its missile-like appearance, its long, thin fuselage with stubby wings, it was nicknamed the Missile with a man in it. This is the Virginia Air and Space Center in Hampton, Virginia. This interactive museum features exhibits spanning 100 years of flight and more than 30 historic aircraft. On this episode of Great Plains, we'll learn the remarkable story of the F-104 Starfighter. A unique plane, the F-104 stays in production for 30 years.
My name is Kenneth Flick. I'm the Educator Resource Manager here at the Virginia Air and Space Center.
Hey Ken, great to meet you.
It's nice to meet you too.
Thanks for taking the time to talk to us today. We're talking about the F-104 today, and I can see one hanging from the ceiling right over top of us. What can you tell me about this specific airframe? Where did you guys acquire it from?
Well, it's on loan from the United States Air Force. It was built and delivered to the Air Force in 1959. It actually is a Vietnam veteran.
Wow. That's rare.
Yes, it is, especially for the 104. It flew in Vietnam in 1965, 66, and 67 on 3 tours. This is the way the aircraft looked originally when it was delivered to the Air Force in 1959.
Encounters with the MiG-15 during the Korean conflict causes an outcry from Air Force fighter pilots for an aircraft that can outperform their F-86 Sabres but is less complicated to fly.
Korean War making new demands on U.S. aircraft, designers are confronted by a problem in the engines that are available to them. A new generation of engines is being developed, but they are in the early stages, and their availability is undetermined.
At Lockheed, a team led by aviation pioneer Kelly Johnson, one of the most innovative aeronautical engineers, begins developing the concept of a single-engine supersonic interceptor capable of sustained speeds above Mach 1. Johnson's reputation as an engineer has already been firmly established. His innovative designs brought great financial rewards to Lockheed during the Second World War. The successful P-38 Lightning, with its radical twin booms and its single nacelle holding the cockpit, was typical of his approach to design solutions. At the same time, in the USSR, designs of new fighter planes continue at a great pace. A long series of new designs appear, and Russia begins to make impressive military aircraft in large numbers. The development of their new planes comes as a shock to many Westerners when MiG-15s appear in the sky over Korea. U.S. pilots, hard-pressed in their Sabres to keep on top of the MiGs, request radical new planes to give them back the advantage. The challenge becomes Kelly Johnson and Lockheed's next project. Johnson realizes the new plane needs to go as high as possible and as fast as possible. He chooses a lightweight fighter. In a short time, he settles on what is to be the F-104's most controversial design element, its extraordinarily small, thin wing. In addition to its size, skeptics aren't impressed with its trapezoidal shape that goes against the recently adopted swept wing design of other jets.
Tell me a little bit about what you know about the design philosophy that Clarence Kelly Johnson had when he built this.
Mr. Johnson actually designed this airplane back in 1954. and it's a very small fuselage, very thin fuselage, generally lightweight for an aircraft of that date, but had an extremely powerful engine for the period, and it has some very small wings. In fact, the wingspan is only 21 feet.
21 feet.
Versus the fuselage of 54 feet. In fact, the wing is so small and so thin that when it was on the ground, they had boots to put on the leading edge of the wing because an airman could seriously hurt himself on the leading edge of the wing.
Get little 104 kisses on your forehead.
On your forehead or your scalp, you know, it would maybe take your scalp off. It was a very, very thin wing.
The new design must go through a battery of wind tunnel tests. Hundreds of variations of the basic concept are examined. Much of the testing is directed at the wing because of the many doubts expressed about its ability to fly and carry a payload. The wing is to be 7 feet long and go from being just over 4 inches thick at the fuselage down to under 2 inches thick at the tip. A new boundary layer control system is needed to direct air from the engine over the trailing flaps, improving lift and safety on landing. The thinness of the wing also means the fuel tanks and landing gear have to be contained in the fuselage. Attention is also focused on the air intakes, seeking to prove that the shock waves around the inlets allow controllable and dependable air supply to the engines. Footage taken near Mach 2 shows shock waves around the model, demonstrating the pressure loads in the ducting under various flight conditions. In additional tests, the F-104 design is bolted to 5-inch Army rockets to demonstrate the types of stresses that high speeds and sudden acceleration can exert on the wing in low altitudes. The plane's tail is designed to be very thin, and many people aren't convinced it is strong enough to steady the plane in flight. Once again, the tests help the team to sort out the best combination of elements. The overall development period, including hundreds of models, will be completed in just 2 years. In 1995, the F-104 demonstration team, known as the Starfighters, was formed to showcase low-level, high-speed aerobatic maneuvers and precision formation flying. The team is made up of 3 F-104s that serve in various roles: training, operational flight test and evaluation, and for airshow performances across the United States and Canada. During the Korean conflict, U.S. pilots come face-to-face with the Soviets' highly maneuverable swept-wing MiG-15. In an effort to keep pace, U.S. pilots are in need of a new fighter jet to give them an edge in aerial warfare. Lockheed hopes their F-104 prototype will be the solution to the MiG problem and starts testing the drastically new lightweight design. After hundreds of tests, little or nothing is added to the original plan. And with the F-104's design sound, a contract is issued for 2 planes to be built. In 1953, with the design of the new F-104 finally agreed upon, manufacturing begins. The first step in the fabrication creates the 3 fuselage models to full scale. Simultaneously, the jigs to cradle the whole planes are built. All over the workshop, manufacturing of the parts begins. The planes on an experimental production run are essentially hand-built. In a flurry of activity after the receipt of the March 1953 contract, Lockheed clears production space, constructs a wooden mock-up, and then, without stopping, builds the two prototypes. The first flight is to take place only 12 months after the signature of the contract. The achievement in the 12 months is astonishing. It is a leap forward in aviation and technology. This kind of accelerated design would be unheard of in today's fighters.
The controversial wings are not made to go through the fuselage, as with most of the fighters of the day. They are bolted to the side with heavy-duty precision-forged aluminum fittings that tie into the wing skin. What Johnson designed is very straightforward in some ways. Ask for a plane that can fly higher and faster than the MiGs, he produces a manned missile.
With its undercarriage retracting into the fuselage in a fairly complicated way, even this has to be subjected to more than the usual testing. The Air Force has never seen a design this drastic before, and puts its trust in the Lockheed and Johnson names. But the F-104 is definitely on trial. The construction of the plane goes ahead rapidly, with the major sub-assemblies coming together at the Lockheed plant. Vibration testing establishes the natural frequency patterns for the entire structure to ensure the plane is safe for flight. On February 25, 1954, the F-104 prototype leaves the Lockheed plant under tight security and is transported to Edwards Air Force Base in California. The crews immediately begin a thorough round of pre-flight ground checks of the plane's systems in preparation for its first flight. The engine for the prototypes is the Wright J65, which proves inadequate in propelling the F-104. With the first flight a few days off, the engine is tested continuously. The new design makes for other adaptations of standard safety systems. In case of emergency, pilots ejected downwards to avoid being hit by the jet's tail. While obviously of no use at low levels, this system allows for a simplified layout in the cockpit and the arrangement of the canopy in the seat itself. Because of the danger of ejecting pilots straight into the ground, later starfighters use conventional seats, firing upward. Although the test pilot has made a skip-off during taxi trials on the 28th of February, on March 4, 1954, the F-104 is rolled out for its first official flight. Satisfied that all is well, he starts down the runway and lifts the F-104 into the air for the first time.
In the weeks of test flights that follow, it becomes evident that the power plant is lagging far behind the Mach 2 potential of the airframe. But the Lockheed concept of the lightweight fighter is conclusively proven.
Despite the prototype's inability to exceed 1.3 times the speed of sound with its current engine, the design has been vindicated sufficiently for the Air Force to order 17 more planes with upgraded power plants as YF-104As. They are later converted to F-104As. The jets are equipped with General Electric's J79 engine, with higher thrust and less weight. In April 1955, one of these finally takes the Starfighter past Mach 2, which is the signal for F-104 production to swing into top gear. For the moment, the intense testing of the two prototypes continues. The prototypes, seen here flying together, are both to be lost in accidents during the test period, which is long and troubled. There are many incidents where bugs in the plane's engine or its other equipment are encountered, often in situations that are very dangerous. One test pilot is involved in an early mishap in 1954 while testing the firing of the Starfighter's high-speed cannon in supersonic flight. After a trouble-free first firing, he starts the plane on another run, ready to fire the gun again. This time, something goes dreadfully wrong, and the plane loses all engine power. The pilot is facing a dead stick landing without the assistance of the boundary control system. The F-104 had a 50-year military operational history and served in various roles for 15 countries, including the US and Canada. More than 1,700 F-104s were built under the military program for various nations. During high-stake test flights of the new F-104, the single engine cuts out in mid-flight. The pilot must maneuver back home with no engine power. He finds himself having to make some very quick decisions. He is about 40 miles from base, high enough, theoretically, to be able to glide back to land. This is what he sets out to do, knowing that he still has a margin to eject from the plane, but also knowing that very soon he will have to commit himself to the landing as he passes below the safe limits for the ejection seat. Even before the hatch is opened, a dirty smudge of smoke shown on the fuselage confirms that the gun has caused the problem. Behind the gun, in the gun compartment, is a hole blown into the plane, where a cartridge has ejected backward through the gun base plate. Relieved that the malfunction is in the gun and not the airframe, the engineers fix the plane and the tests go on. The repaired prototype goes back to the gun testing, but 4 months later there is to be a recurrence of the problems with the cannon. The F-104 levels out for its second firing run of the day. The cannon produces vibrations so severe that the damage is major, and the aircraft becomes uncontrollable. At 50,000 feet, the pilot ejects from the crippled plane. Emergency services respond immediately, and the pilot is recovered unharmed. The Starfighter is a total loss. The first of many F-104s to be written off in crashes. The cannon has been the obvious suspect in the crash, and it is established that another malfunction in the gun has damaged the plane, this time with drastic effect.
One of the weapon systems that the F-104 has is a 6-barrel 20mm Gatling gun, the Bolton Gatling gun. In fact, very similar to the Bolton cannons that were on the F-4 Phantoms in later years.
The design borrows two features from the famous Gatling gun, first patented back in 1862. Both have a rotating cluster of barrels, and both are externally driven. Rigidly clamped together, the 6 barrels give each other support, and the system does not have the whip of a single barrel. In addition, the arrangement centralizes the recoil of the gun. The M61 is driven with electric power from the plane. Each round is fired independently, eliminating the erratic recoil of multi-gun and gas-reloaded options. At the time, the M61 is a new weapon, and the troubles that it causes in the early days of the F-104 are expected with any piece of advanced equipment. A comparison of the Vulcan with the U.S. Air Force's previous preference of machine guns is difficult. In hitting power, range, speed of fire, and the effects of the plane on the gun's actions, the Vulcan has such a wide margin of superiority as to render such an evaluation meaningless, even with consideration of multiple machine gun installations. Contrary to Kelly Johnson's assessment, the military procurement policies after Korea demand multi-role capability. So, despite the origins of the design as a single-role specialized fighter, provisions are developed for the F-104 to carry a mixed load of weapons. Though the Starfighter's superlative performance is appreciated in the U.S. Air Force, it is not seen as sufficient justification for the project, and Lockheed is forced to develop some unlikely attachments for the plane in trying to convince the Air Force to stay with the project. Among these is the trapeze installation to allow the carriage and delivery of the Genie nuclear rocket. This clever launching mechanism is another product of Kelly Johnson's intuition. With the challenge that his plane cannot deliver this device over a combat radius of 650 miles, Johnson announces he can do it within 60 days. The Starfighter's fuselage is already fully occupied, and a major influence on the launcher is the need to keep it out of the way of the undercarriage. With little fuss, the F-104 demonstrates successful firings of the Genie at 56,000 feet, at above 1.7 times the speed of sound. But the ability of the design to respond to such a challenge does it little good in the Air Force's eventual assessment. Lockheed tests a variety of weapons delivery attachments and external fuel tanks, increasing the range and versatility of the plane, but it still cannot rescue the project. The F-104 is very much in the right place at the wrong time. While other fighters are getting bigger to do more things, Kelly Johnson has abandoned all but the essentials in getting the plane sized down to get Mach 2 out of a single afterburning turbojet. But this condemns the Starfighter to a very limited career with the U.S. Air Force. There is simply no way to cram all the rapidly expanding hardware of radars, aiming controls, and other new avionics into the little plane. But the fact that it can do a lot of things that its heavier counterparts cannot do is ignored. The assessment says that the F-104 lacks all-weather capability, lifting power, and range. And these perceived failings are eventually to decide the issue. The project is set for financial failure, but the work that had started on giving the F-104 greater versatility goes on, trying to delay the inevitable and keep the Air Force interested in the plane. The plane's weapons capability includes standard systems, like the Sidewinder. There is no question that the F-104 is in fact an effective firing platform. The plane thrives in the air superiority role it had been built for.
It carried on hard points on the outside of the wings 2 AIM-9 Sidewinder missiles, and could also carry ordnance under the wing. Of course, that would slow down the speed of the aircraft, so it was not used a lot in, let's say, air to ground, but mainly it was a fighter interceptor.
Get high, get fast, try and shoot things and not worry about turning.
Get your man and go home.
Yeah, I mean, I can't imagine with a wing that's designed like that, this aircraft could turn anywhere smaller than about the size of Texas when it was, and that's when it's trying real hard, you know?
More sophisticated radar and fire control packages are developed for the fighter, and prowling B-47 bombers are detected and intercepted with great efficiency. But the Air Force is fully aware of the fighter's capabilities and prefers other options. Beginning in 1956, NASA operated F-104 Starfighters in the extreme regime of high-speed flight research. To further examine rocket-powered aircraft during the late 1950s, NASA modified F-104s with a hydrogen peroxide thruster system to give soon-to-be rocket pilots the experience necessary for flying high-speed aircraft. From the start, the Air Force attitude toward the F-104 is guarded. Before, the Air Force used to accept a new plane into use while it was still being tested, the fly and then fix principle. The F-104 is the first plane to be purchased on a fix, then fly basis. As the prospect of large U.S. Air Force orders fade, another market is quietly revealing itself in Europe. The pure performance of the plane is remarkable, and with its rapidly expanding technical capability, it is maintaining a position as the design to beat. On top of the expansion in the weaponry of the plane, during 1958 and 1959, it is sent on a spree of record setting to reinforce the message of its potency.
It held a lot of airspeed records and rate to climb records too. The fact is, in its career, it broke 7 world rate to climb records, including 15,000, 20,000, and 25,000 feet rate to climb.
In 1958, the Starfighter soon makes up for its limited range by adding in-flight refueling technology. At the time, this is still very new and expensive. To sell into the European market, the F-104 has to display many of the capabilities in ordnance, range, and technical sophistication that have been deliberately excluded from the designer's original concept. Many of the aircraft's capabilities that have become problems for the U.S. Air Force will also prevent sales in Europe. Even though it has evolved into a capable, multi-role, all-weather strike aircraft, the question marks already over the plane mean it has to not only succeed, but excel in the tasks set by its prospective buyers. A German order will require some of the most stringent design requirements, including the capability of speedy takeoffs from short runways. The plane displays that it has the strength to cope with this artificially shortened landing, but the challenge to the pilots is another thing entirely. The Luftwaffe is also concerned with the ability to deploy planes away from established runways in the event of a conflict. Lockheed successfully redesigns the F-104 to show that it can handle zero runway length deployments. First tested on an F-84, the zero runway length system uses truck-mounted rockets. First unmanned and then with a pilot, the launches are executed successfully. Although zero launch capability is never adopted, it makes the Starfighter more valuable in the eyes of the Luftwaffe. West Germany has a pressing need for these kinds of innovations. At the height of the Cold War, it sits on the border between Eastern and Western spheres of influence. It is vital to demonstrate to its neighbors that West Germany has the capacity to defend itself successfully. NATO also needs new arms, and there is a healthy desire to standardize NATO armories. If the German call for new equipment can be met by Lockheed, many other orders could be won at the same time. One of the developments that sees the F-104 concept saved is the two-seat variant. U.S. fighters always seem to have a trainer or reconnaissance version that uses 2 seats, and the F-104 is no exception. The Germans are primarily after a ground strike aircraft, but are also looking for a jack of all trades, and a twin-seat variant is very much a part of their thinking. The F-104 also sees service as an efficient, high-speed test platform. In the specially built F-104N variant, the aircraft is fitted with hydrogen peroxide thrusters to give astronauts experience operating reaction controls in the thin air over 100,000 feet. In the long term, there are to be few performance targets set for the F-104 that it cannot cope with. The pilots, however, are a different matter. There is never a certainty that any individual pilot will be able to cope with the plane. The need for specific training of pilots for the F-104 is a sign of things to come, rather than an exception to a long-standing rule. A properly trained pilot flying a well-maintained F-104 is not at risk. But when an unprepared pilot meets the plane, the combination could be lethal. Lockheed's sales strategy includes a production offset package that will see the planes manufactured by cartels of European aviation companies. The boost for European airspace capability from the construction of these new factories is one of the clinching factors in this successful campaign. When it comes to the final NATO decision, the plane itself performs very well. The competition for the contract is serious, and some of the competitors are very able airplanes, particularly the British Lightning. But by the time the contract is decided, the F-104 has proved itself the outstanding aircraft in the competition. Unlike development, the marketing and sales of the F-104 has been long and plagued by troubles. The plane's reputation as a hot ship has cut both ways. Its unquestioned speed and simplicity can be very unforgiving to the unwary pilot. There are to be over 8,000 flights in the pre-sale test series, using 52 aircraft. Several of the planes are lost through equipment malfunctions and pilot errors. But the Starfighter is without a doubt a pivotal aircraft in the post-war development of jet aircraft. The F-104 Starfighter was popularly known as the missile with a man in it, a name which was trademarked by Lockheed for marketing purposes. However, due to its deathly speed and dangerous reputation, it also acquired some not-so-flattering nicknames, like Widowmaker, Ground Nail, and even Flying Coffin. The F-104 Starfighter is not the first U.S. design to seek lightweight and simplicity as virtues. For example, the Bell XP-77 had nearly gone into production during the Second World War. Even though the design is radically different from others of its time, the controversy surrounding it makes Air Force brass wonder if it's a lemon. The U.S. Air Force phases its F-104s out of operational use by 1967. However, during Vietnam, before the F-104s are completely out of U.S. service, some are to be deployed to Southeast Asia as high-flying MiG-cap for the B-52s and in low-level tactical support strikes. The Russians have also learned lessons from Korea. Where the Starfighter sacrifices almost all in the quest for speed and climb, the USSR develops a radically different requirement. Issued in 1953, this is for a short-range interceptor fighter, the MiG-17. High performance is stipulated, especially in speed, climb rate, and rate of turn. The primary armament is to consist of air-to-air missiles, internal cannon, and a light ground support bomb load. The MiG-17s are an updated 15, with better handling and a more sharply swept wing and tail plan. It is to be built in very large numbers, and though theoretically obsolete when first proposed, it defies this assessment and proves very effective, even in the mid-1960s in the skies of Vietnam. U.S. thinking is totally different. The concept of a simple, stripped-down fighter aircraft is no longer in fashion. The F-104's fellow Century Series aircraft all share a commitment to complex, state-of-the-art technology, each with varying degrees of success. The F-101 Voodoo, F-102 Delta Dagger, and the F-106 Delta Dart see limited service in Vietnam. They all reflect, in their way, the concept of the fighter as a standoff missile launch platform. Theoretically, they are all specialized aircraft devoted to facets of an overall fighter spectrum. During their careers, these divisions tend to fade, as each developed multi-role capability. The F-101 in particular grows into different uses. It is doubtful that any of the other planes in the Century series can compete with the Starfighter. In fact, there are many considerably more modern planes that will find great difficulty dealing with the F-104. The overseas sales program with the Starfighter not only rescues the project from the brink of financial disaster, but makes it into an outstanding success for the company. With the deals on production, it goes into service with 15 air forces, including the U.S., and is the nearest to a standard Western fighter plane to have been produced. The fire control systems and other controls are virtually tailor-made for each country's version of the plane, and it is used in many ways. The F-104 has a reputation for demanding the respect and care of the pilot, but it also has a reputation as the hottest thing in the air. Air forces around the world employ it in a variety of roles and contribute to its development well into the 1990s.
Lockheed maintains its own private starfighter as a promotional device, flying almost constantly worldwide in search of orders. and in later PR efforts to try to rescue the plane from the bad publicity that is attached to it, causing it to be one of the most controversial aircraft of all time.
It is in this plane that Jackie Cochran, hero of the 1930s Bendix races and the Second World War Wasps, becomes the first female Western pilot to break the speed of sound.
With an airframe that was built to fly high and fly fast, that is not always conducive to being highly maneuverable, at least not back then. Today it might be, back then it wasn't. So maneuverability-wise, how was the Starfighter?
Quite frankly, it wasn't the greatest maneuvering aircraft design, again, because of the smallness of the wings. So it took a lot of area to make a turn. Put a lot of G's, especially at the speeds, put a lot of G's on the pilot. So if you want to say one of the disadvantages of the F-104, it would have been in its maneuverability. What it lacked in maneuverability, it more than made up in speed and firepower.
So straight lines, little hooks.
Straight line, little hooks.
Shoot first and keep on going.
The problems of the F-104, from the unavailability of powerful enough engines for the prototypes and then the unreliability of the J-79, continued throughout its early career. The scrutiny and the testing of the plane has been without precedent, and the methods and technology of such testing has never been the same since.
Despite being saddled throughout its lifetime with a horrible reputation and seemingly never free from controversy, the F-104 is vindicated. In its long career, it has carved its own special place in the history of aviation.